Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com panel brought to you by Techstrong and CtrlStack. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I will be covering just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab. You can find that Q&A tab on the right side of your screen alongside a few other options. You'll also find the chat tab where we'd like you to use it for more general discussion. Maybe let us know from where you're tuning in or what role you play in your organization. And of course, before we sign out today, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program today. So our topic is minimizing the troubleshooting tax, 5 tips to increase DevOps productivity. And I'm joined by Dev Nog, founder and CEO at CtrlStack, Jason Goocher, head of customer success at CtrlStack, and we have our very own Mike Rothman, chief strategy officer of Techstrong Group and GM of Techstrong Research. Jason, Dev, Mike, thank you, all three of you, for being here with me today. Mike, do you want to go ahead and get this conversation started?
I do. So welcome. Thank you, Cody. Welcome to Dev and Jason. What we're going to do today is really kind of dig into, one of the nuances of, really kind of scaling up your DevOps environment. And we've been talking about DevOps for a long time, and, we'll get into Predict on Thursday. We'll talk about, kind of 5 of the trends that we think are moving forward. But the reality is we really need to start thinking about how can we more effectively operationalize DevOps. It's kind of everywhere. The fact that people are talking about something else supplanting it means it's really starting to take root in the environment. Until there's something else that people are focused on, they tend to not really take a technology seriously. So we're kind of at the place in 2023 where DevOps is really kind of institutionalized. And that also means that we're starting to find some of the issues, right? Some of the chinks in the armor that make it hard to do things at scale, consistently, and effectively. So today we're going to talk about, 5 or so tips or, kind of ideas that we can use in order to make sure that you're optimizing your DevOps environment. So with that, let me introduce my esteemed panelists, Dev Nog and Jason Goocher. Dev, why don't you kind of introduce yourself, go through your background a little bit so people know it's like, wow, this is a dude that's been there, done that, has the road rash, a couple of T-shirts, I would guess, and maybe some conference badges as well.
And all the battle scars, yeah. So I'm the founder and CEO of CtrlStack. I was in tech from 22 years ago, back at PayPal, before the eBay acquisition, a long, long time ago. And then at eBay, then at Google, was at VMware for a while, did a bunch of startups, and especially the most recent one is the most relevant, I think. So we did Wavefront, and actually Jason was our first employee at Wavefront as well. So we started Wavefront back in 2013, at kind of the very beginning of observability, doing metrics, and then eventually traces and logs and some other stuff inside that whole kind of package as it became part of VMware. But sort of seeing how observability kind of evolved over the last decade kind of led to this idea here with CtrlStack. And so we have 20 years at least of doing DevOps and at least 10 years of being able to see how it's affected other customers from my point of view.
You bet. Jason, love to hear a little bit about your background as well.
Sure. Yeah. So, Jason Goocher, I'm head of customer success at CtrlStack. Been in the tech startup space for a little over 10 years now, pretty much worked with Dev for all of it. As Devin mentioned, kind of both worked together at Wavefront before it was acquired by VMware, and now here at CtrlStack. Primarily focus on the onboarding, troubleshooting, and enablement for our customers as they're coming onto our platform. In terms of battle scars, there was this saying that we always had back away from when we talked about data and the data observability was just eliminate the noise, remove all the noise. There's so much noise out in the world today that make it hard to find the answers you need. So something like CtrlStack definitely resonated with me when it comes to removing some of that noise in the DevOps space and making it much easier to troubleshoot and identify these issues as they're coming in, make it much better for their customers to get value out of their products.
Yeah, and I think that's a great place to start the discussion, right? So what we're going to do is we're going to look at some of the data that we pulled from a recent poll that we've done. And in your handouts area, you can just click on that and you'll actually see kind of the produced pulse meter with our data around that, and our kind of commentary and analyst view around that. But it really does focus on this idea of the amount of time you spend troubleshooting issues that come up, within your DevOps environment. And the first thing that drives a lot of these issues is kind of our first data point, right? And that's how many code or configuration changes happen in your environment daily, right? 17.2% don't know, and I think they thought they were getting some kind of fruit plate or Amazon card if they filled out the poll. Because if you don't know, right, how many changes are happening in your environment, it's kind of hard to figure out, kind of which end is up, right? So those folks are kind of blind, so we're not going to pay much attention to them. But 16%, have less than one, right? 23% have 1 to 3, 19% have 4 to 10, and 24% have greater than 10 code or configuration changes daily, right? So the good news is people are doing stuff. The bad news is, are they doing the right stuff, right? Or are they creating problems, right? So again, what your first reaction? This is surprising, not surprising. Where do you think things are going now that we're at the beginning of 2023? So what do you think this chart's going to look like as we move towards, kind of 23 and then, kind of into, 24? How's this chart going to change?
So I think there's two things to take away from this chart. So the first thing is that these are self-reported numbers, right? So this is what people kind of recall and say themselves, like, I think I had 2 changes yesterday, right? But then if you ask them in deep surveys, you're like, okay, think about all the times you change a feature flag. Think about all the times you scaled up a system or down, right? Think about times you took a Kubernetes action or provision or deprovision something or change a DNS or a network rule. They're like, oh yeah, I didn't do 1 change yesterday. We did like 8, and they have a completely different number. And so I think these are actually like hard floors on the number of changes. People do far more changes, but they're not sure what to categorize as a change. And that's like the first problem. The second problem is like the trends have not been favorable for change velocity. We've actually like had way more changes with every year. We have more systems, more complexity, more dynamism, more external third-party services, things that we're like relying on our third-party vendors in real time, right, with their API calls. So you find folks using like Databricks or Confluent or Snowflake. And when those systems go down, you go down too. They're part of your entire ecosystem, right, in real time, which means when they make a change, you're actually making a system change to you as well. And so those things are hard to quantify. So I think like, we both underreport and underestimate the trend line that's like increasing this change velocity just rapidly at a rate that we actually don't appreciate right now. And we see the outcomes, the symptoms, but don't understand the causes.
Yeah, that's right. And I guess since we're, trying to leave everybody with a couple of tips, right, in order to optimize, kind of their DevOps environment, I would say maybe the first one is know what the hell's going on, right? I guess that's kind of a broad tip. I don't know how
track your changes.
Tippy like that is, but or at least from a visibility standpoint, right? And then track your changes. So not having good visibility. The idea of somebody who says don't know, right, on a self-reported thing. Again, maybe it's their position, but to me, you should have dashboards. You should have kind of metrics that kind of give you a sense of what you're doing in your environment. So that again, if without having this kind of visibility, it's really hard to get a sense that you're going to be able to kind of drive productivity and really optimize your environment.
Yeah, saying don't know is probably not a deliberate philosophical choice. It's probably an accident that they didn't just happen to have a system around that could actually track these things. And the problem is like all this data.
Honest people, Deb, we have like people who are like, wait, I actually don't have this with precision, so I'm going to say I don't know.
This is all on purpose.
Blind spots.
And so I think like, the first thing is that the data is scattered over like, 15 or 20 different systems. And so we have sort of like some centralized records of intent, right? We have ITSM and things like Jira to track like, a service now to say, here's what I plan to do. Here's a ticket. Here's like what kind of happened afterwards with the resolution ticket. But that doesn't track what changed in the system itself. It's a very high level intent of like, here's like the kind of outcome we want to make happen here, right? Or like some big change. But it doesn't say what actually touched the system, what was, kind of changed at the micro level. That's the first level. The second part is the consolidation. So, querying 15 or 20 different knowledge bases at one time is really, really hard. Synchronizing it together, understand the connections. Like it's really impossible to make sense of this like jigsaw puzzle, like on the ground, scattered in piles without having it all connected together. I think that's the second part of tracking is to really connect and unify that data to make it actually manageable and understandable.
Yeah. Yeah, so let's dig in on that a little bit. Not because, again, I think this is kind of a fundamental capability that you have to have in order to really track your DevOps environment. So let's just say somebody's starting from scratch and they haven't done a lot of stuff, and they're really trying to get a sense of what's the best way to kind of streamline my path to this visibility that they need. Right. Where do I start? Is it, hey, just kind of instrument everything, pop out, open telemetry, kind of put it into a database and look at it? Or are there specific tooling or categories of tooling that they, need to look at? So if you're starting from, again, a dead start, what are the first 2 or 3 things that you guys recommend folks do? And, obviously by CtrlStack could be number 4, right? But, kind of before we get to that, what are some of the fundamentals that I think folks may not, kind of have thought about?
Yeah, so I think the first thing that you have to do is make sure you instrument the application and the infrastructure and the services, right? Make sure you have all those categories of parts of your system kind of tagged and able to send data into be able to centralize that data. So you have kind of the typical group of telemetry. Melt is metrics, events, logs, and traces. So you want to be able to have all those 4 different buckets. And we had this idea maybe 5-10 years ago where it's maybe one data type will kind of take over the world and own everything. We realized that's actually not the case. You need to have all of those data types and other ones as well, because they really have different ways of projecting down the data and to show you different aspects of your system. So you really want to have all those different types working together. But the hard part is connecting them, really trying to figure out, what log goes into which metric, how do they tie together when you have an operational issue. So number 1 is instrument data. I think we're pretty mature now as an industry on instrumentation. We weren't back when we started Wayfair. That was 10 years ago. That's a very, very different world where people are just trying to understand metrics and kind of coming off the first phase of logging. But now we have so many great data types, other ones like histograms and so forth. And yeah, the second thing I think is really to say for folks making changes, what is your process? What does that change process look like? Is there an organizational, kind of consistency in how you record changes? So the worst case, the very beginning of the customer journey is basically folks who are making changes without telling anyone. And then maybe a day later saying, oh yeah, I did this yesterday on Slack. And so there's no way to track that stuff in real time. No one knows how to interpret what, a 3-word, sentence means in Slack. It's not tied to the exact entity and the exact time, the exact type of change. It's just too high level and too vague.
Right.
And so I think getting that precision and that kind of real-time process around change management is super important as we go forward.
Yep. Jason, anything else on your end? You're there smiling, looking pretty and stuff, but we want to make sure you can participate too if you like.
No, absolutely. I pretty much say the same thing Dev said, right? You got to have consistency across the way that you instrument your application, the way that you get it out there and build on it. So yeah, consistency is there. And then the source of truth. That's the really big thing. When you are launching a product and you want to get your platform out there for end users, it's very important to make sure that you have a good source of truth across all of your teams and the different processes within your application. That way, it's much easier to pinpoint these problems when they are happening.
Yeah, that's right. And I think one of the things, and this will lead into our next data point, because I think it's a really good segue, is the complexity that's been driven by I wouldn't even say gradual, right? Kind of the avalanche of adoption that you have in terms of dev teams that are adopting, agile and DevOps types of approaches, right? I'm working with a client right now. They've got somewhere in the neighborhood of 200 different application teams, right? All in different levels and stages of embracing, DevOps. Some are really good at it. Others are not so good at it, right? I'm advising the security team to kind of try to them get, kind of their arms around this thing. But you've got architecture, you've got, again, deployment and operations that are trying to figure out, which end is up. And that really brings up our next data point, right? Which is the tracking of every production change centralized across all applications and infrastructure, right? We start with 15% say yes. All right, great. That's where you want to be, right? But another 45% say not yet, but they're moving in that direction. So they understand that that's kind of where they want to be. And 41% say no and have no plans to do so. I won't put them exactly in the bucket of don't know about how many changes you have there, but it would seem that, kind of this distributed anarchy-based environment may not work too well over time. But again, as you scale up your environment, as you have more teams that are playing into, kind of the DevOps approach, The more changes you're going to have, the more issues you're going to have, the more time you're going to spend troubleshooting, right? So that starts to, get at what it is that, kind of one, we want to talk about, but two, what is one of these blind spots that I don't think folks really understand. Right, Dev, I thought your point about, kind of folks self-reported these changes, and it's probably a hell of a lot more than that. When you ask folks about, not just downtime, but how much time they spend actually trying to figure out the root cause of these issues, in a lot of cases, they're going to underreport it just because, again, the last one felt painful, but the one before that, you hardly even remember. Right. And the one you're going to do next is going to go great because you've done all these, specific things. So love to get your feedback on one, kind of what we can do to get that 40% that don't understand, right? Kind of the importance of centralizing a lot of this reporting and a lot of this telemetry, and also start to peel back a little bit about some of these causes of the troubleshooting tax and really how difficult that gets the more you scale up your environment.
Sure, I'll kind of chime in a couple of things that I think are really important to centralizing these things. That if you haven't quite thought about this, you don't understand where the value is. But I'll let Dev jump in after that. So first off, like when you are talking about so many different applications and services that you're managing, it is very hard to manage that across several different products and UIs. Understanding where the information is captured at, where it's kept at. Expecting a developer, an SRE, to know where that information is kept at, very difficult, especially when you're having to do so much context switching. But ultimately, what that leads into is the main point I have, which is the mental load that comes into having to connect all these dots and build that model in your head. It's a real thing. You've got family issues when it comes to like how do you actually like take in and manage your children, things like that. But when it comes to applications and your software, it's the same exact thing, right? What application talks to the next application, which service connects with the other one. You have to be able to build those things and connect them together, and it's just so mentally taxing when you don't have a good understanding of where those paths lead in the first place. Dev?
Yeah, I totally agree. I think there's 2 points that I'd make here, and the second one really just is what Jason said. The first thing is doing the change tracking early on makes that troubleshooting so much easier later, right? And you got to either pay the small price up front or the big price later on. If you don't brush your teeth now, you're going to get cavities, right? So you want to avoid that at all costs. It's really easy to brush your teeth and just track the changes while they're happening, because after the fact, we've all been through this. If you've been in tech for any amount of time, you've been in the situation where it's like, something bad has happened. No one knows what happened. You're scouring Slack and the logs and Jira and ServiceNow and just trying to figure out what happened, what changed here. Is it our fault? Is it Cloud's fault? And then maybe 3 hours into it, someone's like, oh yeah, Jared made that change. And no one tracked that. No one knew about that. The entire team got wasted for 3 hours. Customers were complaining for 3 hours because no one tracked that change. And it could have been a few minutes as opposed to being a few hours. And so these things magnify and amplify in the outcomes to customers. And that's what we're trying to avoid here, right? With a little bit of just basic hygiene up front around how we track changes is just much, much safer and much easier later on when things actually do hit the wall. The second point is, basically, if you don't know what the changes are, it's really hard to tie cause to effect and say, I know what impact my change had on the system. And therefore, if there's a bad impact, I can trace it back to a change and be able to work around it or reverse it or roll back. That stuff becomes exponentially more difficult when you don't have that cause and effect model, either in your system or in everyone's head on the team. And having the head of everyone on the team is really hard, really expensive. So we suggest trying to put as much burden on the system as possible to do that.
Yep. So obviously visibility, tip one, centralizing a lot of your kind of production, change data. I think is certainly another tip that we can throw at folks as stuff that if you want to scale up your environment are pretty important to really think about. I'll throw another one in here too, Dev, and you got me thinking about that a little bit more, which is really the importance of having some type of central group that is responsible for tool chain, right? And reporting structure and what metrics are you going to, track? Because again, every team is doing a different, application. They've got a different set of constraints, a different set of, inputs, outputs, and outcomes that they're trying to do. But in terms of operating the environment, as an entity, right? As your entire application and technology estate, there's a certain set of things you got to have. Right. So without that central group kind of saying, hey, you do need to, centralize production stuff. I can throw a little bit on, kind of aggregating security telemetry. And, we can probably think about 1,000 other things that, whether we want to call it a center of excellence or, some other central group architecture, policies and standards, don't care. Right. I'm not religious about what you call it, but that somebody is looking broader than just my application team and trying to understand what it is that they should be doing, what it is that they need to be aggregating, gathering, and really to help standardize some of these troubleshooting processes, right? Because you learn, right? The more you do stuff, the more you learn, the better you get at things. And if you're not leveraging that information right across the entire environment, and you're just missing a huge opportunity to mature your environment.
That's right. And you see this oscillation. There's actually two oscillations in the industry. So one is between centralization and decentralization, right? You want to in one phase, really unify and centralize things. Other phase, it's distribute the teams, let them kind of handle themselves and they can kind of figure it out independently. And the other part is basically being a generalist versus being a specialist. And with DevOps, right, kind of traditional legacy DevOps, everyone kind of had to be a generalist and be kind of good at everything. And they never got deep at anything, right? They had to really master every part of the stack and have to be sort of shallow experts at being able to handle the tier one issues. But they all hit the wall, right? They can't be the expert in Nginx and MySQL and Snowflake. And so it's just too much knowledge for everyone to have to master. It's not efficient that way. And so now we're seeing those two trends kind of push back the other direction towards, I'd say, more centralization and more specialization, right? And so I'd say platform engineering is sort of that new kind of buzzword around how do you take these centers of excellence, give them the tooling they need to serve everyone else inside the organization, right? Let the developers be developers, try to take off the easy stuff from their plates and let them just handle kind of the small deltas, right? That are kind of unique or quirky about their services, because otherwise you end up with 20 or 50 or 100 different service teams inside these large orgs that are having to fight over, well, which API call actually failed? Who's at fault here? Who started it? Who's the one who can fix it? Who's got to work around it? And it just turns into anarchy at that point.
Yep. Don't like anarchy. I guess in some situations maybe, but not when I'm trying to scale up,
Yeah, you want to harness the individual power of every team to have that autonomy and go full speed ahead, but they're held back by this tax, right? By having to be generalists, by having to handle this huge DevOps burden. Our goal is to try to make all those teams as fast and autonomous as possible. And you can't do that with the current process and the current data.
Nope. And I think, as we kind of transition into, kind of our next data point, right? This is outcome, right? This is an outcome-based situation. What's the mean time to repair for an outage in your environment, right? This is the stuff that's impacting customers, right? Getting in the way of your ability to be successful, right? Again, so we'll start over on the right. 22% don't know. We're gonna that. Let's just. Deb, I like your perspective there, right? They're not precise enough, so they basically said they didn't know, as opposed to the fact that they may actually just not know. But you've got 7% greater than 24 hours, right? Kind of 19%, 4 to 24 hours. Again, this is significant downtime at this point, right? 26% of the folks are sitting there saying we have significant downtime. Another 25%, 1 to 4 hours. And only, kind of 28% out of the whole is looking at, kind of less than 1 hour. Right. So again, first gets back to our visibility aspect of that. And if you don't know, or it takes too long, or you don't have precision over, what that is, it's really hard to, one, understand the problems, and two, really marshal the resources to fix that over time. Right. And that's really the key. If you're sitting there going, I've got systems that are down for, 4 hours to over a day, I've got something systemic in my environment that I have to really, start, thinking about how do I address. Right. But when we get into the less than an hour, 1 hour to 4 hours, that kind of feels like a long time. Maybe it's acceptable. I think some of it has to do with the application environment. But in your guys', experience, right, where is the biggest parts of, this? So we talk about an outage. which could be from the time something goes haywire to the time I got it fixed and back up and operational. If you kind of look at this as a continuum, am I spending 50% of my time trying to figure out what the hell happened? Is it 70% of my time? Is it, will it vary for each one? But again, as we start to try to peel this back and help folks understand how to really favorably impact, some of these issues, where are they spending their time in this, kind of outage scenario?
Oh, yes, this is a loaded question. There's a lot of time wasted when it comes to MTTR, right? You've got the actual diagnosis part of it, but then there's just wasted time of getting the pages, getting the right people involved, making sure that you're communicating in the right spots, knowing where to go find the information. So there's a lot of wasted time there. So you can just clean up from that process, can obviously shrink it down. But ultimately, I think with more of this kind of containerized architecture and complex systems as we see today, there's so many moving parts and there's so many possibilities of causes for the effect that you see that it just essentially opens up an endless number of paths that you have to go, kind of follow the breadcrumbs down just to be able to say, is this the right answer? Or no, I've gone to a dead end. Now I need to switch over to another thing. And sometimes you don't really have a good context, especially with those kind of less experience, of knowing where to start that. So I think just having more of an educated guess that tells you where you should focus your attention based on the symptoms that are being seen is probably one of the key things right now to shrinking this number, just giving them a good starting point of where to begin their journey.
Yeah, on my side, I'd say I think it's pretty shocking how bad this has gotten. Like, we actually have not gotten better in my 20 years in the industry, right? We had this kind of distribution back 20 years ago, and it still looks the same. Like, we've actually scaled our systems at the same rate that we've scaled our ability to manage them. We haven't gotten better relative to the burden there. If you look at this chart here, I think the median is probably 2-3 hours if you don't count the folks who are in the don't know bucket. That's expensive. So Splunk did a survey where they found that every hour of downtime was about $500,000 to $1 million per hour, right? And that's pretty expensive. So we're looking at $1 to $2 million per outage, on these kind of folks' data points right here, and lots of consequences downstream, right? If you have a SaaS company, that means you're maybe violating your SLA. You're going to have chargebacks. You're going to have reputational risk. If you're an e-commerce company, that means lost transactions that are going to go somewhere else to the competitor who's selling the same thing and actually is up at that point in time. If you have an API first company, right? People rely on your API and you're down. They're going to find a backup. They're going to look for the more reliable option. Say well, why do we try vendor 2 just in case vendor 1 goes down again? And at some point, if vendor 2 does not go down, they might say that's now our primary, right? So there's a lot of risk that comes out that goes beyond just the downtime itself that leads to these sort of follow-on effects for the whole business.
Yeah, if I can also add on to that too, Dev, I would just point out that, in our experience, at least at Wavefront, and I imagine we'll see at CtrlStack too, customers, you can build great loyalty and great relationships with your customers, but essentially one negative experience really needs at least 3 positive experiences just to balance it out. Mm-hmm. So that tax of customers having so many options available to them today, mm-hmm. they're going to go look around. And then also the market for developers and SREs, it's hot, right? There's a lot of companies out there looking for people. And the more taxing this outage portion and actually having to diagnose and triage, the more of an impact and taxing it is on the actual developers and SREs, the more of a moral hit they take, the more opportunity it is for them to look elsewhere and see what other opportunities are out there, which is just, losing experience on your team. So yeah, definitely hits on a lot of different areas.
Yeah. So we just got a question in, and I'd love to get your guys just, kind of basic stuff. What is MTTR? And again, forgive us, right? We just kind of jump in sometimes, and because we're, kind of immersed in this world every day, sometimes we don't realize that, kind of there's some acronyms that the audience may not be as familiar with. So meantime to repair, right? There are a couple of different aspects of, that. Sometimes it's respond, depending on, kind of which R you want to use. But Jason, you just got a quick view of kind of how you view MTTR?
Yeah, absolutely. So I actually wrote an article not too long ago around MTTR and explaining kind of the differences and the nuances of it, right? So there's mean time to repair, there's mean time to recovery, right? Which, there's, again, it's all of the little nuances, right? Some of those MTTRs are really focused on once you diagnose the issue, how quickly can you get from the diagnosis to the resolution? There could be the focus on when it is actually acknowledged via an alert versus customers reaching out. So there's a lot of different nuances to MTTR. But ultimately, the idea is mean time to resolution, mean time to repair. How do you go from an incident or a problem to a solution? And it's just measuring different time frames within that.
That's right. So you know, as we move along, right? I mean, I think that this is a great, you know, kind of framing for the business problem that we have when things go down, right? You know, Deb, you said it great, right? You know, kind of you're losing customers, you're impacting, Jason, your data point of, you know, a negative impact. You know, you've got to have 3, you know, kind of positive experiences to just, you know, kind of stay even. We really want to, you know, kind of eliminate or, you know, certainly minimize the amount of time customers are impacted by some of these system downtimes. So let's kind of dig in a little bit to those components here, right? So that time, how much is spent identifying root cause when issues develop, right? Again, we've got a bunch of folks that don't know. They need to be a little bit more precise. So we'll give them a mulligan on that one, right? But less than 10%, 13%, right? 11 to 30%, 27%, right? 31 to 50%, 25%, and greater than 51%, 16%, right? So if we looked at, you know, back of the envelope, right, over 40% are spending somewhere over, you know, between a third and half of their, you know, kind of troubleshooting time just on trying to figure out what the hell happened, right? So, you know, again, obviously that's part of, you know, kind of the hypothesis for why you guys are doing CtrlStack, but it would be really helpful to get a sense of, you know, kind of how can I start to streamline this, right? When we start to think about, you know, tips that folks can, you know, take back with them, right? Obviously visibility, obviously organization, obviously instrumentation, you know, kind of a lot of these things that prepare us for success. But, you know, again, how do we get more towards the 11 to 30% and the less than 10%, right? Rather than the greater than 51% of what I'm doing is just trying to figure out which end is up.
Yeah, so, you know, the numbers are pretty stark here. So what we see is that about 70 to 75% of all outages, of all incidents, are caused by internal changes. We're mostly at fault here. We're the ones who are making changes through code deploys or feature flags or whatever it happens to be. And so most things that happen can be traced back to something that we're doing internally, not to the cloud or to a weird customer behavior. It's actually like something that we're doing ourselves. And so that's why the change tracking that we talked about at the beginning is so key, because that is, in most cases, the reason that we have these problems, right? And so if you don't track those, it's really hard to identify the root cause because it's not able to be accessed by someone quickly. It's not like, you know, kind of there in some centralized queryable format. It's in someone's head, or it's in a random Slack thread, or maybe like, you know, 3 comments down or whatever. And that makes this number, you know, much higher. And actually, like, if you look at these numbers, we've seen like servers across thousands of people out there in the wild too. Like they have numbers like 66% of all of downtime is spent trying to troubleshoot the root cause. It's like the vast majority is finding out what the root cause was, and then actually remediating it is a minority of the time. It's actually faster to fix it once you know what the problem was than vice versa. And so I think, like, you know, we have this problem of, like, you know, root causes being very complex. They're getting more complex now. We have more complex systems, much more, like, you know, external dependencies. These things make this whole troubleshooting process much more difficult than they were just even 5 years ago, I would say.
Yep. So, you know, again, I think that what we really want to make sure that everybody understands is, without, you know, kind of spending the time, right, making the investment in both the instrumentation of your environment and, you know, kind of the aggregation of all of that data across all of your different teams, it's going to be really hard to make progress on this. Right, you're starting from a standstill. Every issue you have, every problem you run into, and again, when you're doing that, you're just it's kind of like Groundhog Day every day. You know, you wake up, something's out. What the hell do I do? You check a bunch of different systems. What the hell do I do? What's going on? You know, again, it gets to be, honestly, you know, kind of demotivating for the team. Right, you know, if they're doing the same thing, if they don't feel like they're making progress, and the thing that really resonated, you said, based on the last slide, Dev, right, is that, you know, you've been doing this for 20 years and the graph is pretty much look the same.
Yes.
Right.
We've not gotten better.
And it has not gotten better. And part of that is inherently we have been able to perform better, right? But the systems are so much more complicated now. right? So what we're not doing, we're not figuring out a way to jump, kind of do a generational jump ahead of, kind of the environment of the technology. We're, again, grinding it out every day just to stay in the same place, right? And that can be demotivating for folks, right? So again, kind of making the investment, thinking about instrumentation, right? Centralizing a lot of these environments, aggregating the data, right? But then what? Right, so I've got all this data in there, right? I've sort of decentralized these things. What are the things I'm looking for, right? How should I be, kind of evaluating these changes? What are some of the things that you guys do, right, on the new platform that are somewhat unique to really help identify which change really correlated to which specific outage, so folks can start to make the jump, right? They say, oh, if I actually have that data and I analyze it in this way, I can get some kind of, favorable alert or favorable outcome that, that I didn't have before. It'd be great to walk us through, kind of that process for, how you think about the problem now.
Yeah, so what we really did at CtrlStack is to look at what people already did right now in industry. So what did we do for 20 years at Google and PayPal and eBay and VMware and other places that I worked at, and Jason likewise? If you look at what people do when they troubleshoot, they're looking at two big buckets of possible cause. They're looking at the when and the where, right? The when is what happened recently, what happened around the same time, what's a correlated event, right? That could have been at play here. And looking at the where, what else happened nearby, right? What was changed on that same machine, or maybe like, one level up or downstream, kind of what's in the neighborhood of like that symptom that we're seeing, right? This is how we track like, kind of like this detective work of troubleshooting incidents, like the when and the where. So what we did at CtrlStack is actually reflect both those processes in the data itself, right? The when is pretty easy. A lot of events have timestamps you can kind of correlate very easily. That stuff has been around for a while. The hard part is the where, right? Tracking what's connected to what else in real time and making that the foundation for a very efficient search through the entire application. So we actually build the connectivity between all of the data, right? Between the metrics and the logs, saying here's how they connect together. Here's how the machines connect, right? So going from a metric on like, one service pool to a metric on a different service pool that talks to the first one is incredibly hard in a traditional metrics database, right? They don't have any semantics for like what's talking to each other. That's like in some other like, trace database, and they don't really talk kind of real time. We actually built that whole model from scratch to say, here's what an operations engineer would do to search from a symptom back to the root cause, right? All the way through this like sort of graph, essentially walking a path of investigation. So the way we think about it internally is like we have like, the smoke. That first symptom, maybe it's an alert coming through PagerDuty or some weird anomaly in a metric or some weird log line. We're saying like the next step is where's the fire? Is there a fire at all? And where is it? How big is the fire? And then we trace it back to that first match, right? What's the match that began that fire? Because that will tell you how to go fight the fire afterwards. We try to make that entire process much, much faster by putting in the data first and then automating the investigation on top of that data.
So like Chat GP, right, or whatever they're calling that thing, you can ask it a question and then, the answers pop out based upon a whole bunch of, kind of, automated machines in the background. Is it sort of like that?
So that's actually, it's funny you say that because we've seen this revolution with generative AI the last 6 months now. And generative AI requires the data to be in the right format to actually understand how to query against it, to understand it. And so building that graph for the whole system makes it extremely amenable to things like ChatGPT. So we actually have now in our product the ability to ask natural language questions of your data and get back an answer in a few seconds. Say like, I want to see all the machines that are connected to this other pod and have this like, CPU load, and just pull it out as if it's like a query language, even though it's not structured at all. It's basically just English coming into the system here. And so, you've had all these like, essentially SQL-lite types of query languages that you have to memorize, understand, and like, debug and stuff. And we just get past all that to get straight to natural language using things like ChatGPT.
Yeah, that's that's really cool, and for a couple of reasons, and then we'll move on to our kind of last topic that I want to hit on. But as we get more and more adoption of DevOps, right, we have more and more people that kind of come into our little ecosystem, and we can't assume that all of these folks know what we're talking about. I mean, I think that that question we got, what is MTTR, is a great example of that, right? Folks are here to learn. They're here to get, kind of a couple of tips to, optimize their DevOps, kind of production. They hear troubleshooting tasks and they're like, oh, I want to learn about that. But we can't assume that they actually know what we're talking about. right? So, kind of having that natural language processing, having that, more humanized interface as opposed to having to, understand some wacky, Boolean, and regex, type of existence to get the information you need out of your observability platform. Being able to frame this as a more specific question, I think, again, just broadens the tent, right? Kind of really opens a lot of the technology up to, again, folks that may not be as experienced. And we're going to be dealing with a lot of those people because we can't scale up the experience level to the need that we have out there in the environment. And I think that's really across a lot of different technology disciplines. We have to use technology more effectively in order to make maybe a little bit less experienced, maybe a little bit less sophisticated practitioners be able to operate at a higher level, right? I mean, it's just a necessity at this point. So that brings up our, last topic that we have here. And this is really understanding, getting a sense of, kind of which data sources should I be looking at and how do these overlap and do I need all of them, right? Because listen, the reality is we're entering a situation of economic headwind, right? Decreasing budgets, folks tightening their belts, again, right? 18 months ago, kind of it's the heyday and everyone's like, woo, let's spend money, right? So we can just be like, you know what? I'll take one of each. I'll take an observability. I'll take a code commit. I'll take a change logs and, give me two of everything, right? On the left side of the menu, right? We're in an environment right now where I don't think that's a great assumption that we'll be able to do that, moving forward. So if we think about 51% sit there, say they look at their observability data, right? And then, kind of you look at the rest of them from there. And these aren't mutually exclusive, right? This was a multi-select. So folks could, kind of select multiple things here. But where does it start, right? Where does it end, right? You just talked, Deb, pretty convincingly about, why this graph of understanding kind of changes and impacts and outcomes, right? And the relationships of them are pretty important. But how does that stack up against, observability? Do I need observability to kind of, use a lot of the analysis that you're talking about? So is this a later thing? Is it an earlier thing? How do I start to really think about, the tooling that I'll need in order to get this level of visibility?
So you definitely need all this. And the problem is it is expensive. It takes a lot of outlay to handle all the different data types and handle these things at scale. But one of the problems is that in most observability companies, and people know this internally, that 99% of all data that's collected and paid for and stored is never queried. It's never analyzed. It's never used in any form by any alert or person or dashboard. And so we're paying a lot of money for a lot of data that doesn't actually get used, right? So this is actually where I think that next level of better algorithms, in part with generative AI and other kind of techniques that are coming on right now, are able to tell you which data actually really matters for your operations and which ones don't, right? Because we're paying 100 times what we actually use here on observability, which I know myself from my own history. Everything else, let's say, we're actually underutilized because they don't have high volume. You don't have 100 million points per second of change logs. It's just not that fast compared to metrics where you can have multiple millions per second of points coming through. I think there's actually a missing category here too, which is the data between the data, right? So this is something that we have not really collected or monetized before as an industry, but tracking how these things connect together is, I think, the next level of value to make it more efficient and more usable, right? To actually get that ROI from the data you have and are paying for. And so the way I think about it is we had this era, I'd say back in the 60s and 70s, of having file systems be the source of knowledge. In the late 70s and early 80s, we had this kind of next level of relational database, right, on top of these file systems. And so Oracle and Sybase and so forth kind of came out and changed how we look at data and query data, right? Everything with file system databases, they kind of have the same data. What's different here? Databases have all the indexing and all the connections, right? The relations between the tables here, right? And that makes all the difference in the world. We're still in the file system era of observability, right? We have buckets of data, but they're not connected together. So going from one data to another data, it's like going from a file to another file. You have to look in the file and kind of track a string and go search for the string somewhere else. We're not quite to the relational era of observability. That's the next level here, and that's the data that's missing here. This kind of connection between the data to make these whole processes much faster. And so troubleshooting, remediation, incident management, provisioning, all these things rely on the connection between data. someone's got to make the connections. It's actually us right now. It's the people on your team who are making the connections and paying the cognitive load and the price for that, right? So we're saying it's just a little bit of extra data. The change data and the connections can make that whole process much cheaper and get your team back to what they should be working on, which is feature velocity, especially on the developer side.
Yep. Jason, you're working with customers every day, right? So are you seeing a similar type of thing where they're just overwhelmed by the amount of crap that's in their, observability environment, and they're underutilizing, some of these other, pretty interesting data sources just because they don't either, kind of understand how these things connect, or they just, are so overwhelmed with everything, they don't have a sense of what they should be doing.
Yeah, no, absolutely. To Dev's point, right? There's so much data that is captured today. Everybody says like, oh yeah, go track it, get a metric for it. But if you don't know how to use that, you don't know how to utilize it when it's relevant, when it's not, it's just useless because you don't know when to go back and reference, right? It's like muscle memory. You have to use things more and more on a regular basis to know where you should be using it in the future. And if you're not using your metrics enough and you don't know how to utilize them the right way to monitor the true health of your environment, you don't go back and reference it. So yeah, it's about too much data being out there and then the relevance of it. That's really the big part, I think. You can have data sources from, observability, from your code commits, from your change logs. But if you don't know when it's relevant and when to use the relevance, it's just a moot point, right? You really need something that lets you capture everything, but also tells you when you should be utilizing those different data sources,
That's so. Is it time for me to bust out the old, adage that's so overused it makes me sick at this point, right? We have so much data, but not enough information. Blah blah blah. Right. But the fact is, it's true. we can make fun of it all day, and the fact that listen, I've been doing this a long time too, and 20 years ago we had maybe a little bit less data, but we still didn't have any more information, and now we got a lot more data, and we really need a lot more information. So that's great. We've got a couple minutes left, kind of deal with questions. If anybody kind of here has any questions, just pop into the questions tab, and kind of ask away. I've got one that I want to start with, right? Because I think it's pretty pertinent, and it hits on a lot of the organizational things. Is that a lot of the dev, right, and a lot of the ops, kind of even a lot of the security folks. I mean, we've been talking, in terms of DevOps breaking down these silos. Yeah, I'm not sure, right? I'm a little skeptical in terms of, kind of to what degree these silos have really been, broken down. So if you're sitting there with an ops perspective, you've got access to observability, you want to get better view into change logs, right? You want to get better visibility into, kind of source code and a lot of those things. How do I do that, right? How do I make a case to a developer that this stuff matters? Because again, that's always been one of the constraints, is that they just don't care. Their job's to ship code. Now they get to do a pull request, code's in there, somebody else deals with it, beyond that. And obviously that's a little bit of a, hyperbolic type of example there. But the reality is, you do have competing incentives for a lot of these different groups. So how do we get there, right? How do we get everybody on the same page to understand that this data within the data, right, is something that's going to help them do their job better, regardless of whether you're at the front end of the process developing, kind of the middle part of testing and getting the deployment, or, kind of the end part in terms of operationalizing this on a daily basis.
So something really interesting happened in the last 10 years with DevOps is that developers, by becoming more responsible for operations and getting more involved with productions, actually had to pay the price of their own code, right? This is something that did not happen 20 years ago. You often could throw your code over the wall, and the ops team would take care of it. Like, you had very, very different organizations, and developers kind of get away with like a lot more, right? And so I would say now developers pay that tax pretty directly, and most developers love writing software. We do it on our free time on the weekends for fun. Like, we just love this process. We don't always love having to go fix production when there's like 17 pairs of eyes staring at us, right? Maybe virtually, like on a terminal or on Slack. And so the more we can do of the former and less of the latter, I think that is a great incentive for all developers to be able to get back to like what they really love to do. And like, that's how they're evaluated, right? It's really like, make the feature part of that product like sing, and try to like, push off the ops work as much as possible to automation or to the teams that specialize in that stuff. So I think the incentives are definitely getting there much more than they were before. I also think developers have a natural curiosity about how their code is behaving on production, right? Source code by itself is like the DNA of code, but once it's out there, it's like the living, breathing entity that actually like creates the value for their customers, right? They want to see who's using my code, how are they using it, like what are the interesting use cases that I want to extend my code in that direction. So I think like, that's actually been a great boon for developers to understand like, what is happening on production. And so I think they're pulled in the right ways to understand what's happening on production. Like maybe their code caused a huge problem or caused a slowdown. They want to go fix that kind of proactively. So I think like, the change in the last 10 years of DevOps has actually made that incentive system much more aligned and much better. But now the downside obviously is the tax is enormously high. So Scalar did a survey a couple of years ago where they showed that companies that do more aggressive deployments, kind of push out code at least once a day, have extremely high taxes, right? So 72% of all the companies that push code at least once a day report that at least half of their engineering resources are spent on troubleshooting and debugging, right? So you hire great software engineers, they're fantastic, they come in day one, they were hard to find in the first place, and then you chop off half their productivity to go maintain the past as opposed to building your future, right? The future of your company. And that's going to get worse as we have more aggressive deployment, more complex architectures. So we have a lot of trends saying we need to solve this problem before we hit the wall of like, an 80% tax or a 90% tax. It has to get fixed before that. And the data between the data is a way to go make that happen right now at scale.
Yeah, I actually love that vernacular, right? Data within the data, because it helps to really understand that you already kind of have most of this. You're just not doing the analysis to interpret kind of what it means within the context of everything else. So, Jason, I have a question for you, right? So, to what degree, and again, you're dealing on the customer success side, so you want to help folks kind of get some specific value out of this data within the data. So what are some of the milestones that folks should look at? I mean, they're not going to get to, perfect visibility. They're not going to get to perfect organizational alignment on day one, right? So they've got to kind of map out a process for how they get there. What does that process look like, right? So when you're working, with kind of customers, how are you managing their expectations to what's reasonable to expect, and when, and how should they get there?
I don't know, Deb, do you want to take that? I think you might be able to answer better.
Why don't you start and I'll augment you.
I don't know. I don't know the right answer. I don't know. There's a lot of information out there. We need to be able to get customers into the answers a little bit faster. We need to be able to comb through the different applications that are out there to find the answers. I mean, I don't know, Dev. I imagine you probably have a little bit better context on it.
Yeah, I think of like, the data by itself as being sort of like inert in some ways. It doesn't actually do anything until the person looking at it does something with it. And that's the process you want to automate and leverage up. And that's the hard part, right? So we've had all these approaches in the past, right? Of like, writing automation code or maybe documenting what you did before, trying to like get that tribal knowledge out of like, the architectural genius's head and into like, Notion or something else like that. And that process is broken. Like it just doesn't work. It doesn't scale. It doesn't work for like, companies that go beyond like a kind of a non-trivial size. And so I think a big part of this whole direction is how do we grab that information out of people's heads in a much more efficient way that doesn't feel like a burden, that feels like it's actually natural to how they work. And this again is I think generative AI actually plays a huge role in taking that sort of implicit knowledge of how things work, that process knowledge, and getting it out there into code, into artifacts that can be used by the whole team to make that data kind of sync, right? Because as Jason said, like very articulately, like we have like this raw metric data or raw log data, but how it's actually perceived, the semantics behind it are the key value, right? That's like 99% of the value, not just the numerical data by itself out of context, right? Just a point sensor essentially in space somewhere. And so I think that's the hard part of this whole kind of DevOps process. Like how do we take that tribal process knowledge and get it out there for everyone to understand and to use and to discover in a very efficient way?
Yeah, I would say like discoverability, I think, is a big thing there. Obviously when an incident happens, like you're drinking from the fire hose, you are in it right then, you're dealing with the issue, and that's the type of experience that helps you get better down the road. But there's also kind of the downtimes, right? The peace times. And you don't want to waste the peace times. Obviously, you're going to be developing new codes and new features for your customers. But when you have outside time outside of that, like it's important to be able to go and discover those relationships, to be able to jump through that, right? That architecture in your mind, I think, was a big thing for us when we first started talking to design partners at CtrlStack, was this idea of company architectures. How is everything connected together? You get a new engineer coming into the system, and usually you're dealing with like an image of an architecture. It's outdated. It gets outdated very quickly. You don't know how things are all talking with one another. So being able to discover those relationships in peacetime, I think, is a very good way to build up that knowledge and share it across the team.
Yeah, I like that concept. And again, what I was going at, Jason, I mean to put you on the spot there, man. But I mean, to me, a lot of it gets back to trying to get fairly small, somewhat discrete, very quick wins from this kind of data, right? So if you're in a specific situation and something, kind of goes south, and you can help, kind of understand and correlate the fact that, about a couple of milliseconds before this portion failed, this change was kind of committed, and it kind of ran through this specific kind of set of tests on the pipeline, and that's the stuff that they didn't know, right? And just by showing somebody, hey, you didn't know this, and this can help really understand, and piece together what really happened in a much more expedient fashion. That's the kind of stuff we're looking at, right? That's the kind of stuff that we want to use to start to appeal to the developers and start to, make the case that, again, this isn't something that we can fix, overnight, but what we can do is we can get a little bit smarter about how we're understanding how all these pieces fit together. And then we can, really use that and leverage that as a mechanism to start to improve, again, that connective tissue between all these different systems that will help, make the ultimate environment a lot stronger over time.
Absolutely. I think, something you said earlier, really just resonated with me. I think we don't want to break down every organizational silo. There are some walls that are there for a reason, because we can't scale up as humans to understand 200-person meetings or whatever. But we do want to break down the operational data silos, have other teams be able to get to your data to understand what is your system doing to theirs, and vice versa, to be able to debug and troubleshoot and understand how the system behaves as a whole much, much faster. I think that's a problem that we haven't solved yet in the kind of legacy of the observability industry. So we have lots of metrics over here on team one, metrics over here on team two, but no one else knows how to use or interpret them. That's the kind of knowledge and semantics that we have to be able to push out easy for other teams to be able to self-serve that knowledge to understand how to debug during incidents.
Yeah, that's right. And with that, I think that's a great place to, kind of stop at this point. Really fantastic conversation. Oh, we've already did the panel discussion. All right, good. So what you'll find in the handouts area is the pulse meter. So all this data is presented, as well as the context around it. Obviously, we were able to get into it at a much greater level of depth in the event today. But we also, again, want you to kind of see, kind of within the perspective of a takeaway, kind of how this data fits together. Just before I hand it back over to Cody to give away some, late Christmas gifts for everybody, on the Amazon cards. We do have Techstrong.com coming up in March. So sign up for that. That's really kind of where we start to hit on some of the, digital transformation growth that we're starting to see and how that plays into it. So that'll be an event that we do virtually, again, on March 16th. We have Predict 2023 this Thursday. So if you have not signed up for that, please do that as well. It's going to be a great show on that front. And with that, I do want to thank Jason Goocher, Dev Nog. I mean, really, guys, I thought this was a fantastic conversation. Hopefully everybody got a little sense of the things that they can do to improve their DevOps environment. And again, look at the data, right? Instrument the environment, start breaking down those silos where it makes sense, and maybe leave them where it doesn't. But ultimately start thinking about how you can leverage and gain value out of that data within the data, right? That connective tissue that we have in between all of these different data sources that, again, provide that context that we need to find and fix problems a lot faster. So with that, thanks a lot, guys. I thought this was great.
Thanks, Mike.
Thank you.
All right, Mike,
And
thanks so much.
To you, Cody.
Thanks so much for putting such a nice bow on that. I appreciate you closing us out. And Dev, Jason, thank you both so much for joining us as well. So I would like to remind our audience that today's session was recorded. So should you like to rewatch this program, you should receive an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So like Mike mentioned, we do still have 4 $25 Amazon gift cards to give away. So our winners are Martin S., Aaron D, Yogesh S, and Lynn N. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift cards, but if you don't happen to see that email, please do check your spam folder. I'd like to thank CtrlStack for sponsoring today's program. I'd like to thank Techstrong Research for conducting a lot of the research that went into our pulse meter today. And to our audience who's been with us for the past hour, thank you so much for joining us. We really value your time, and we also really value your feedback. So as soon as we close out, there will be a survey that will pop up on your screen. Tell us how we did today. Tell us what you'd like to see on future programs or any other feedback you'd like to give us. But otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, and I'll see everyone soon.